Hello, my name is Lee Moreland, and this presentation is on ecosystem production in the ocean. Primary production in the ocean is conducted by phytoplankton, and they're using photosynthesis in the euphotic zone to create their organic carbon. The euphotic zone is just the area in the water column that sunlight can penetrate to, so this can vary depending on how much sediment is in the water. These are very small animals. They're about 5 to 100 microns in diameter, and they've been conducting photosynthesis in the ocean since the early Precambrian. And their respiration is credited with converting the Earth's early atmosphere from a reducing environment to an oxidizing environment. So over a very, very long period of time, these animals change the atmosphere of the entire planet. So just like houseplants, these photosynthesizers need nutrients as well as sunlight and water, but they're just floating around in the ocean. So they need the process of upwelling to get their nutrients. So upwelling can occur in several ways, but one way is wind blowing across the water's surface. Wind will be diverted to a right angle of the direction of the wind, and when you're close to a coastline, that will cause the water below it to be lifted up to the surface. And water below it will be much cooler than the surface water. And then these waters from the depths will be nutrient rich because of debris that's fallen to the bottom of the ocean, such as dead animals. This picture just shows the concentration of chlorophyll in the oceans, and as you can see along the coastlines, it's much more productive because that's where the upwelling is occurring. Areas within subtropic latitudes on the west coast with prevailing offshore winds are the most productive. So Peru, California, and Africa are some of the most productive spots in the ocean. And primary production on the inner shelf can be 60% higher than on the outer shelf, and it can be 270% higher than in the open ocean. Secondary production is similar. It's 60% higher on the inner shelf than the outer, and 260% higher on the inner shelf than the open ocean. Primary production in the oceans is also conducted by the chemoautotrophs, and they're using chemosynthesis. So they're oxidizing inorganic compounds with nutrients and carbon molecules to create their organic molecules. And they don't need sunlight. They live at extreme depths in the ocean, so near sea vents, the ocean's crust, inside the crust, cold seeps, whale falls, or isolated cave water. And their populations are much, much smaller than the phytoplankton. Secondary production in the ocean is conducted by pretty much any animal group that you can come up with. Mammals have evolved on land, but they've returned to the ocean. They've re-evolved into the ocean to feed in the oceans. Birds, we've all seen birds dive into the water after fish. Fish, of course, reptiles such as sea turtles. Certain amphibians can tolerate a little bit of salt water. Cephalopods such as octopus, etc. Food is pretty much everywhere in the ocean. It's just kind of floating all around you. And a lot of these animals have developed huge migration patterns to follow the productivity hotspots caused by seasonal variation. This is just an example of how productive a food chain in the ocean can be. This is a food chain with just 3 links in it: phytoplankton to krill to baleen whales. So phytoplankton, like I mentioned before, are 5 to 100 microns in diameter. Krill are feeding on these tiny, tiny animals, and krill are only about 5 centimeters. Baleen whales feed on krill, and they can be as large as 112 feet and weigh 190 tons. They're the largest animal on the planet right now, and they're the top of this very short food chain. And they do that by just swimming through the water with their mouth open, filling it up with water, and then shoving that water out of their mouth through this filter you can see in the picture, and that's called baleen. But this is just an example of how productive the ocean actually is.